is here. I know Ali for many years. He brings a wealth of experience from his career as a consultant, corrosion engineer, having worked on numerous projects across the globe, including the UK's North Sea, North Africa, Middle East, and South Asia. His work experience with leading companies such as Aramco, British Petroleum, Chevron, and many others have positioned him as a leading authority in the field. Ali's contributions to the field are very big and impactful, including the development of Morshed Corrosion Management Model, MCMM, in 2012, authoring 5 books on asset corrosion management, and his role as an educator and consultant. Welcome again, Ali. We are very happy to have you. Please go on, and floor is yours.
Oh, thank you very much, Mir, for a very kind introduction. Hello to everybody. I know you are connecting from different time zones, so I have to say good morning, good day, and good afternoon to all of you. It has been a great pleasure to have the opportunity to talk on the World Corrosion Day. I would like to thank Young EFC and in particular Naomi and Mir for providing me with this opportunity to talk about corrosion and how best to tackle it. I'm going to share my slides with you and hope you can see my slides. Can you see the slides now?
Yes, Ali.
Yes, perfect. I'm going to talk about corrosion engineering and corrosion management. These are two different terms, but unfortunately, these days they are treated as synonyms and identical by many of us. It's very important if we are dealing with a corrosion problem, we would know what the differences between corrosion engineering and corrosion management are. It's a short presentation, less than 1 hour. I've got around 25, 26 slides, and I try to be as concise as possible. At the end of the presentation, I will share with you my email address. So if you have got any comments, questions, or suggestions regarding this presentation, please feel free to get in touch with me. So the contents of today's presentation, obviously, we will start with the objectives first. Mir was so kind enough to provide a kind introduction on me, so I will skip that bit about myself. Then I will proceed to discuss what corrosion is. Of course, we all know what corrosion is. That's just a reminder. And then I will be asking, why do we still encounter corrosion in the industry in spite of all these technological advances? And what or where the gap is, why we still get corrosion, or corrosion is still regarded as a common or major integrity threat to many assets. I will continue by discussing what corrosion engineering is, how do we define the corrosion engineering concept, and then, more importantly, what the traditional integrity management view is and what its shortcomings are. Thereafter, I will proceed to define the corrosion management concept. At that point, we would see what the differences are between corrosion engineering and corrosion management. I will briefly review the benefits of corrosion management applications and then proceed towards conclusions and recommendations. So the objectives we have got here are distinguishing between corrosion engineering and corrosion management. This is very important. We have to know what the difference is. The problem is because in the past several years, corrosion management has been in great demand in many industries and in many countries. Many individuals and many organizations are selling or marketing their corrosion engineering products under the name of corrosion management, and that creates a lot of confusion. The next objective is to highlight the inherent shortcomings of the traditional integrity management view. It's a view which is based on the corrosion engineering concept. I will explain it to you later. Then I will proceed to clarify what exactly corrosion management is and what it is not. It's very important, as I said earlier, to appreciate the true meaning of the corrosion management concept. When we know what it is, then it would be much easier to proceed with corrosion management applications. The next objective is to truly appreciate the role of non-corrosion engineering-based integrity management measures. As I said earlier, corrosion is still, unfortunately, a major integrity issue in many industries, in many companies. But the main focus of most such companies is on corrosion engineering. They do not take into consideration the significant role of non-corrosion engineering-based integrity management measures. One example I can give you is that some of the projects or companies which have been complaining about having corrosion problems or having corrosion failures do not have a corrosion engineer. They had not recruited a corrosion engineer in the first place. Even though corrosion is regarded as their main integrity threat, there is not a specialist corrosion engineer to help them to solve such corrosion-related problems. And the last objective is to encourage younger corrosion engineers to learn the real corrosion management concept and its true applications in the industry. So once we know what corrosion engineering is and how it differs from corrosion management, it becomes easier to deal with corrosion problems from a corrosion management point of view. So let's go back to the first and the basic question. What is corrosion? We all know that when we have got a metal or an alloy which is exposed in a corrosive environment, we can have an electrochemical reaction taking place, and that electrochemical reaction will result in our metal or alloy to gradually lose thickness, and its characteristic like toughness, like strength would gradually change. And for us corrosion engineers, this is this loss of thickness which becomes very important, because if we are dealing with a system which is under pressure, we all know that below certain thicknesses our equipment can start exploding. So, corrosion is still a universal integrity issue, as I said, in spite of all the latest technological advances in metallurgy, in chemistry, in inspections, in electronics, in coatings. Corrosion in many industries is still a major issue, and the question we have to ask ourselves is that what or where this gap is. Why do we still get corrosion? Maybe the way we have been trying to control and mitigate corrosion has not been a thorough or efficient method. And if that's the case, then what is the better solution? It appears that a better solution is offered through corrosion management applications. And for us, the first step would be to know and to define what corrosion management is, to get training on corrosion management, and then to proceed on implementing corrosion management. I was talking about this gap earlier. I've got a few examples for you. These are very sad examples because you can see how easily we can make trivial and childish mistakes and then get corrosion and corrosion failures. This is a pipeline section just arrived from storage. and it's ready to be fitted into a pipeline which is being constructed. As you can see, this section has water, and water is pouring out of this section, and it has already suffered from tangible internal corrosion. And obviously, when you use such corroded items when building a pipeline, you should expect a much lower operational life from your pipeline than if you were to use pipeline sections in pristine conditions. This one is another example. A trench has been dug to install or insert a pipeline, and they have not removed the water. You all know, if you are building a new pipeline or a pipeline network, you have dug the trench and it's full of water. If you do not if you do not remove the water, then water would enter the system under construction. There were many cases that I was amazed with internal corrosion cases associated with dry gas distribution systems, and later I found out that during the construction phase, due to such poor practices, water had entered the system, and later during the operation, they had internal corrosion issues. Again, here is another example. When we studied corrosion engineering in university, one of the first points that they taught us was not to connect two different metals or alloys in a corrosive environment. Here on the left, we have got a flange made of carbon steel. On the right, we have got a flange made of stainless steel. And they were connected to each other without any isolation. And in less than 2 years after commissioning, the carbon steel flange, as you can see, has suffered from extensive corrosion. And the design life or the intended life was to be 30 years, but this is the condition just after 2 years or less than 2 years. And tens of such wrong connections were fitted in this particular project, resulting in extensive corrosion of the carbon steel flanges. Here is another corrosion case. You're looking into a structure made of reinforced concrete, and as you can see, the reinforcement has already suffered from corrosion again shortly after commissioning, and it was simply due to poor construction practices during the construction phase. Another case, because of poor treatment or processing, we have had treated seawater, but still oxygenated, running through bare carbon steel. And as you know, dissolved oxygen corrodes carbon steel pretty quickly. And we have had a failure here in a very short time after commissioning of this system. Again, it could be regarded as a design mistake, or it could be regarded as a shortcoming in water treatment and not removing the dissolved oxygen from the water stream. So the question is, now we have seen this gap, or we have seen some indications of this gap, but what and where the gap is. If I want to make it easier or to categorize it, I can say that we have got two main different classification of this gap. On the left, the gap comes from shortcomings in design, material selection, transportation, installation, purchasing, hydrotesting, operation, inspection, monitoring, documentation, and procedures. And the right-hand side, I can say the gap is because of changes in the feed composition or changes in operation process, team structure, and methodologies. Going back to the left column, we just saw some examples relating to some of the points listed here. There are a few other ones, for instance, hydro testing. You know, when you hydro test a piece of equipment, you are supposed to use water with a specification like the oxygen has to be removed, it has to be treated with corrosion inhibitor or oxygen scavenger or biocide. And unfortunately, in many cases, the water which was used for hydro testing did not receive any treatment. It was not injected with any chemicals, and then the water, the poor quality water which was used, actually, the hydro test operation was extended for months or sometimes up to years, and the result was a piece of equipment which, when we took over for operation, it had already corroded severely internally. And in some cases, after the hydro testing or after the extended hydro testing practice that we took over the system, it was not fit for service anymore. Operation is another parameter. Sometimes we make changes to our operation and make some areas of our process systems a dead leg, and dead legs are areas where the corrosion rate could exceed, dead legs are areas which could suffer from very high corrosion rates, sometimes even several millimeters per year. I have used two different ink colors here on this slide. Some parameters are written in black, some parameters are written in blue. The blue ones, like inspection, monitoring, documentation, and procedures, are the non-corrosion engineering ones. The inspection, for instance, parameter is that sometimes we do not, unfortunately, in some projects, we do not carry out any inspections until the first signs of corrosion appear. The same goes with monitoring. They do not do, or they do not install any corrosion rate monitoring system. They do not do any sampling. They don't see any value in that until corrosion failures start appearing, and then they start fitting rate monitoring, corrosion rate monitoring equipment into their process systems. Documentation is another area of shortcoming. In some projects, we don't have isometrics, process flow diagrams, even PNIDs. We don't have any reports, let's say regular corrosion reports or annual corrosion and integrity reports. In the absence of such documentation, controlling and mitigation corrosion could be a more challenging task. And regarding team structure, the example I can give you is that, as unfortunately I've seen several times before, some of the projects or organizations which complain about having a lot of corrosion issues and corrosion failures even do not have a corrosion engineering position in their team structures. And if corrosion is regarded as one of their main integrity threats, it cannot be explained or justified why they do not use corrosion engineers in their companies or structure to tackle corrosion. So, what does create this gap? If I want to be very both precise and concise here, in summary, I can say in 99% of the cases that I've been studying corrosion issues and corrosion failures, two root causes or two culprits have always stood out. The first one has been inadequate communication. The second one has been inadequate competency. So, in other words, if you tackle competency and communication, if you try to improve these two items, you will see significant improvements in your corrosion control and mitigation systems. You would see that your corrosion control system would function with much greater efficiency and performance. And that brings us to the next point, which is which options do we have for corrosion control and mitigation in our company or in our organization? At the moment, we have got two options when we create an asset integrity management system or an AIMS for our company. Under the AIMS, we are presented with two options. One is to control corrosion through corrosion engineering. The other one is to control corrosion through corrosion management. The first option, which is based on corrosion engineering, I call it the traditional way or the traditional mentality. And the second option, which is based on corrosion management, I refer to it as the modern approach or modern way of asset integrity management. Let's look into corrosion engineering first, because later I will be defining the concept of corrosion management, and I would like to clearly distinguish it from corrosion engineering. So if I define corrosion engineering, then it would be easier for us to understand what exactly corrosion management is. Corrosion engineering can be defined as the design and application of methods to prevent corrosion. In other words, corrosion engineering is the design and application of parameters which have a direct effect on the corrosion rate or the corrosivity of the environment, or both. Let's look into corrosion engineering a bit more closer. Corrosion engineering has got three main components: design, material selection, and environmental control. So if you decided to proceed with corrosion engineering, you have got these three components. Under each component, you have got more options. For instance, under design, you have got crevice control, no metal mixes, corrosion allowance, use of a cathodic protection system, and ease of access and replacement during the operation stage. Under material selection, you have got these options: using metallics or non-metallics, using coatings, and using claddings. And under environmental control, of course, you have got pH control, temperature control, velocity control, and using inhibitors, corrosion inhibitors, scale inhibitors, or adding other chemicals into the system like biocides or oxygen scavengers or any other type of chemical intended to control and mitigate corrosion. And that takes us to the traditional integrity management view. It is defined as the notion that corrosion control or mitigation is mainly implemented via the corrosion engineering discipline. This notion is referred as the traditional integrity management view. So it says if you are working in any industry and you have got a corrosion problem, then corrosion engineering is your solution. And corrosion engineering has got three components: design, material selection, and environmental control. So it tells you that if you have got a corrosion problem, if you want to identify it, then focus on design, material selection, and environmental control. Then if you want to rectify it, again, your solution has to come from one of these three components or a combination of them. It does not take into consideration non-corrosion engineering factors. For instance, it doesn't tell you if you are visiting a project, visiting a company which is suffering from a lot of corrosion problems, look into their team structure and see whether they have got a corrosion engineer or not. As I said, some projects or companies which have been complaining about having a lot of corrosion issues are those which have not recruited a corrosion engineer. So there is not a specialist who can help them to tackle their corrosion problems. Let's look into the traditional integrity view in more detail. It says more precisely the traditional integrity management view when trying to tackle corrosion problems mostly takes into account corrosion engineering based factors or parameters, which have a direct effect on either the corrosion rate or the corrosivity of the environment or both. That is, in many cases, it does not take into consideration the non-corrosion engineering based or non-technical factors or parameters such as inspection, corrosion rate monitoring, fluid sampling, data management, communication, competency, corrosion control matrices or plant integrity windows, and even the presence of the corrosion engineering position. It is very important if you are a corrosion engineer and you have been tasked with corrosion control and mitigation for a company or for a project to take into consideration both CE-based, corrosion engineering-based, and non-corrosion engineering-based parameters. An example I have given here is data management. So many times I have come across oil and gas operators that collect various data like inspection, corrosion monitoring, and fluid sampling, but they never analyze and process the data. They accumulate data for several years. Then after several years, they come to you and say, we have got this wealth of data, and we would appreciate if you can process our data, analyze our data, and tell us what is happening with our assets or equipment in regard to corrosion. This is not the right approach. If you are continuously producing data, you have to continuously process and analyze your data to create an integrity picture to determine what your current corrosion rate is, to determine what your existing corrosion damage mechanism are, and then decide what the relevant and pertaining corrosion control methods should be. In many of the oil and gas assets that I have visited, they still do not know what corrosion mechanisms they are dealing with. As such, they cannot devise the relevant corrosion control measures, because if you don't know what mechanism you are dealing with, how can you decide how to tackle it or how to mitigate it? Because in many cases, the root causes of the encountered corrosion issues and failures are the non-corrosion engineering based or non-technical factors or parameters, then the traditional integrity management view has a limited capability in correctly and comprehensively identifying and then rectifying such corrosion issues. Therefore, for proper and thorough asset integrity management, the asset operators or asset owners require a more thorough view, approach, or mentality which takes into account both corrosion engineering-based and non-corrosion engineering-based factors and parameters. Hence, the advent of the corrosion management concept. When I started working as a corrosion engineer back in 2002, my mentor, who was an extremely experienced corrosion engineer, told me, Ali, be careful, because what we were taught in university is not going to be fully useful here. There are still many other things that we have to take into consideration. I said, like what? He said, like the factor of communication or the parameter of communication. Communication, or more precisely, the lack of communication, can contribute to a great deal of corrosion problems. And the funny thing, or the sad thing, was that in all these years that we studied corrosion engineering in university, not a single lecturer told us about the significance of communication. And it took me many years to learn the fact that communication, or the lack of communication, was one of the most important root causes of the corrosion problems that we were facing initially in the oil and gas and then in other industries. So if we have realized that the integrity management view, or the traditional integrity management view, which takes into consideration only corrosion engineering based parameters, is not capable of thoroughly and efficiently control and mitigate corrosion, then we have to move forward into another mentality or approach or model which takes into consideration both corrosion engineering and non-corrosion engineering parameters and factors. Hence, the definition of corrosion management. Unfortunately, there are many different definition of corrosion management concept being offered at the moment. Some of them simply assume that corrosion management and corrosion engineering are identical. Some of them say or claim that corrosion management is risk-based inspection. And there are some other funny definitions for corrosion management, but in my humble opinion, they are not very practical ones. Here, the definition I'm offering, or my preferred definition, is that corrosion management is the process of reviewing the required integrity management measures, regular monitoring of their performance, and the assessment of their effectiveness post-commissioning. So the corrosion management definition offered here has got three processes inside it. The first one is the review or the integrity review, followed by performance monitoring, and then the last one is the assessment of the effectiveness. So it's saying first, you have got integrity management measures. An integrity management measure I will define in the next slide. It has to include both corrosion engineering based and non-corrosion engineering based parameters. It says first you have to review them to ensure they are still useful, relevant, practical, and up to date. And then you have to monitor their performance. You have to measure how they have been interacting with the corrosion rate or the corrosivity of the environment, or with the total number of leaks, corrosion leaks you have had. And once you do monitoring and you monitor their performance, you will come up with a figure in terms of corrosion rate or the corrosivity of the environment or the total number of leaks you had last year. Then you compare this figure with an agreed figure from your own company or from a national or international standard. If your measured figure falls within that agreed or accepted envelope or range, then your existing corrosion control measure is deemed effective. If not, you go back to the reviewing stage and try to find out why your particular corrosion control measure has not been effective, or it has not been performing very well. And that takes me to another very important definition, which is the definition of the integrity management measure concept. It says anything which contributes to the overall integrity management system or influences its functioning and outcome. Integrity management measures are either corrosion engineering based or non-corrosion engineering based, and examples include design, material selection, communication, competency, and procedures. Here, I am trying to highlight a difference, a distinction, a very important distinction between the traditional integrity management view and the modern view, which is based on corrosion management. In the old view, as a corrosion engineer, you only would be concerned with the corrosion engineering integrity measures, such as design, material selection, and environmental control. But here I'm saying, because of so many corrosion failures, corrosion issues we have had that had their root causes in non-corrosion engineering based factors, then as an asset corrosion engineer, when you are trying to tackle corrosion, you have to take into consideration the non-corrosion engineering based parameters as well. For instance, if they are not carrying out inspection, you have to ask why. If they are carrying out inspection, but it's not risk-based, it could be time-based, condition-based, or consequence-based. You have to ask them why they are not using risk-based inspection and they are still using time-based or condition-based inspections. We all know that if you use a risk-based inspection methodology, the corrosion failure preemption capability of your company can be improved, because a risk-based inspection, if the inspection scope is determined using the criterion of risk, could help you to preempt your corrosion failures before they turn into failures. So this is very important. As a corrosion engineer, your integrity management measures are divided into two different classes: CE-based, corrosion engineering based, and non-CE based, non-corrosion engineering based. If you want to successfully control and mitigate corrosion, please take into consideration both of these different classes. And that brings us to a typical corrosion management model. At the moment, we have got, I believe, at least three well-known corrosion management models. The one I'm presenting here emphasizes on the fact that corrosion management, the purple box, covers both corrosion engineering-based and non-corrosion engineering-based integrity measures. On the left, we have got the three boxes: design requirements, material selection requirements, and environmental control requirements. They relate to the corrosion engineering integrity measures. And on the right-hand side, we have got four boxes: inspection requirements, corrosion rate monitoring requirements, management requirements, and failure risk assessment requirements. The third box on the right-hand side, the management requirements, I call them management requirements because the parameters listed underneath have to be managed properly. And in my humble opinion, I have listed 12 parameters there, and these are extremely important and totally indispensable for any asset corrosion engineer who is interested in thoroughly and comprehensively control and mitigate corrosion in their pertaining assets. These 12 parameters include registers, strategies, procedures, data types and their processing, databases, documentation, communication, asset corrosion control document, corrosion control matrices or plant integrity windows, KPIs, key performance indicators, team structure and competency. As I mentioned earlier, communication and competency are the two most important parameters here. So if you are a corrosion engineer, you have been tasked with managing corrosion in your company, the best areas to start implementing corrosion management is to focus on competency and communication. See whether the corrosion engineers, integrity engineers, inspection engineers, maintenance engineers have got adequate competency or not. Then if corrosion is a major issue in your company, see whether you have got monthly or regular corrosion meetings. If actions are assigned to different individuals related to existing corrosion problems, and those actions are capable of resolving the existing corrosion issues. If regular corrosion reports are produced, if such regular corrosion reporting leads to annual corrosion reports or annual integrity reports being produced. So these are all components of communication, and through improving communication, you would be able to significantly improve corrosion control and mitigation in your company. And corrosion management applications bring about many benefits. I won't go through all of them, but here are a few examples. Determining existing and future corrosion damage mechanisms. As I said, unfortunately, in many of the operating companies visited after more than 10 years, they were not sure what exactly their corrosion damage mechanisms were. As such, they could not come up with a solution to tackle those particular damage mechanisms because they didn't know what actually was causing the corrosion. And this situation had been going on for many years, resulting actually in no actions against corrosion problems. And they were spending a great deal of money on repairing, replacing, and the assets suffered from a lot of unplanned operation shutdowns. Devising or improving the relevant management measures. As I said, under management requirements, we had 12 items. If you focus on those 12 items, you would be able to make significant improvements in terms of corrosion control and mitigation in your company. Inspection and integrity management become more risk-based. Of course, we never had adequate resources to inspect all different locations in our asset. We have to assign resources in a smart way, and that smart way could be using the criterion of risk to plan and implement our inspection and integrity management activities. Optimizing corrosion costs, improving the corrosion failure preemption capability. That's again another very important item which we never were told about in university. And if you can introduce, or if it already exists in your company, if you can enhance it, then you will be able to find areas which are moving toward becoming a failure. But before becoming a failure, we would be able to preempt them, and that would save you a great deal of time and costs. Increasing asset uptime, extending asset design life, enhancing communication and teamwork, and improving competency. So these are different benefits of corrosion management applications. And that brings me to conclusions. The first one, corrosion remains a major integrity threat for many industries. The traditional integrity management view keeps failing to efficiently and thoroughly mitigate corrosion because it relies only on the corrosion engineering concept. The corrosion management approach offers significantly more options for both the identification and then the rectification of corrosion issues. As I said, when you visit various assets, sometimes their shortcoming or their fault is not on the corrosion engineering side, but on the non-corrosion engineering side. So for instance, they are carrying out inspections, but the inspections they are carrying out is time-based, and it is not risk-based. By changing their inspection to risk-based, they would be able to better realize which areas are suffering with higher corrosion rate, and as such, plan ahead for their better corrosion control or mitigation or their future repair and replacement. Hence, lesser number of unplanned operation shutdowns. The corrosion management concept takes into consideration both corrosion engineering based and non-corrosion engineering based integrity management measures. As I said, if you are a corrosion engineer, please take into consideration both types of integrity management measures. Corrosion engineering is a subset of corrosion management. Thus, by becoming a good corrosion management expert, you could become a knowledgeable and capable corrosion engineer as well. And the last conclusion is most of the current postgraduate corrosion education still focuses on corrosion engineering. As I said, I spent myself years and years in different universities learning about corrosion, but not a single time I was even told about the significance of communication and how by improving communication we can improve corrosion control and mitigation. And that brings me two recommendations, very few simple recommendations. The first one says, when looking for corrosion management products and services, ensure that they are not merely corrosion engineering ones, being marketed, packaged, and promoted under corrosion management guise. The problem we have got at the moment, as I said earlier, because corrosion management is increasingly becoming more popular in various industries, more individuals and companies are offering corrosion management services. When you come across such individuals or companies, ensure that in whatever they are offering, it covers both corrosion engineering based and non-corrosion engineering based integrity measures. In many cases, when you look through what they are offering, you see they are only offering services in the areas of design, material selection, and environmental control, which makes their services pure corrosion engineering based, but they are nevertheless marketing and promoting their services under a corrosion management title. Learn exactly what corrosion management is and what it is not, then use it more efficiently compared with corrosion engineering to tackle your asset corrosion problems. As I said, when it comes to corrosion management, because it covers more types of integrity management measures under its definition, then it provides you with more options to identify and rectify your problems. So it can help you to more successfully and more efficiently control corrosion in your asset. The best areas to start implementing corrosion management principles in your company are communication and competency. These two items I discussed before. This is just a reminder, and it won't cost you an extra single penny. If you want to start implementing corrosion management in your company, just review and find out whether you have got adequate communication and competency within your integrity management team or not. If the answer is no, then try to improve on these two areas. And the last one, the last recommendation says, if you are a university corrosion course director, incorporate the corrosion management topic into your corrosion curriculum to produce more capable and successful corrosion engineers. And that brings me to the end of this presentation. Thank you very much for your time, patience, and attention. It has been a great pleasure to be able to do this presentation. I would like to thank again the young EFC and in particular Naomi and Mir for having kindly provided me with this opportunity to talk to you today. Here you have got my email address. Feel free to contact me to send across your comments, questions, or suggestions that you might have. And I don't know if Mir would like to mention anything or to add anything here, or we have got maybe time for a couple of questions.
Thank you so much, Ali. It was, as always, enjoyable for me to listen and learn from your experience, content of education, and all the things that you want to provide very comprehensively, especially at the end by recommendations. If from the audience we have questions, please kindly raise your hand, and we have a room for a couple of questions. So till they thought about their question or they come up with question, I have one question.
Okay, I'm very happy there are no questions. It could mean that my presentation was so comprehensive that I have managed to justify the fact that corrosion management should be regarded more seriously, and they don't have any questions or comments or arguments about it. So that makes me very happy. What is your question, Mir?
Priorities like the audience. I see a raised hand. So, Mudassir Malik, please unmute yourself and ask your question.
Hello, everyone. Assalamu alaikum, Mr. Ali.
Hi.
Pleasure seeing you after a long time. Uh, really, the presentation was so detailed, and as presented by you, it is phenomenal. As you have rightly highlighted regarding the a lot of organizations who dominate the corrosion engineers. And I myself have faced this problem, and I'm struggling trying to convince the management to implement the right corrosion management policies. And I think my point is this, that we need to initiate. I mean, if you can initiate at least to try to educate the people on some, like this platform you have now. We can extend this and create kind of awareness where we can send our message, try to convince them through, by any means. Maybe this is the best podium or platform we can use, so people like me or you who are trying to save the assets and actually the from the catastrophic incidents which unfortunately can happen, and which are being ignored by these, I can say, the capitalists who just want to save the money for other things. So I think this is the best initiative, and this is the best thing you have highlighted today in this presentation. Thank you so much for this lovely presentation.
Mudassir, alaikum salam to you. Hello to you, my friend. Good afternoon to you. I know you are 1 hour or 2 hours ahead of us. Thank you very much for your kind words. Thank you very much for your nice feedback. The point you raised is a very important one. Sometimes we are very eager to start implementing corrosion management principles, but we don't get enough support from our managers. What I can suggest is that books have been written in this regard, papers have been written in this regard, trying to share this knowledge and experience with others. However, if your managers, for instance, do not, and I can expect that, do not have enough time to read through such books or papers, what I can suggest, and it does not cost you a single penny, is that to arrange it with me, and I will do an online presentation on corrosion management for your colleagues or for your managers. It would take around 40 to 45 minutes. And here, this way, I can share the awareness, share the knowledge with them. And through such presentations for the senior management, you might be able to get the required support and resources from them.
That would be wonderful. That would be great, actually. We can do that. In fact, I don't want to do it only for my company. Like, I have many people in my circle. I mean, lots of companies are out there. I would wish to do it for everybody. Like, but I know at the end of the day, it costs money. We cannot do it free of cost. There is something I mean, because you will not do it every time, right? So we need to do it in a systematic way where we can save your time, and so we can think on this. I can reach to you on your email, and we can discuss on this.
Yes, yeah, please do reach me. And as I said, it's for me, Mudassir, a pleasure to share such knowledge and information, and it shouldn't cost anybody. I don't charge anybody for talking. And just you have got my email address, get in touch with me and we will organize something together.
I appreciate that. I appreciate that. Thank you so much. Thanks.
Pleasure. You are most welcome. You are muted, I believe.
Oh, I'm sorry. Thank you, Mudassir. One of my questions were asked by Mudassir. I was like going to ask, what is your suggestion for young, especially young corrosionists when they start their job, that you tactfully answer to that. Thank you. If there is another question, please again raise the hand and unmute yourself, ask the question. Otherwise, I can. Okay, there is a question coming from Ali Morshed. Yes.
Yes, hello everyone, and thank you, Dr. Morshed, for your nice presentation. I have one question. As you mentioned, there are two basic management systems, corrosion engineering and corrosion management systems. I want to know if there is any statistical result that shows the corrosion management system is more beneficial than corrosion engineering and the traditional one.
Ali John, hello. Hope you're fine. Nice to hear from you. Thank you for the question. There are some papers, at least one which has provided some figures showing you how by application of corrosion management principles you have been able to, for instance, optimize your costs. I don't have such figures, especially financial figures, but from some of the projects that I had worked on, I have been receiving feedback months after I left the project, or sometimes years after I left the project, that they have been able to save, for instance, sometimes millions and sometimes tens of millions of dollars. And these figures to a side, Alijan, the point you have to always remember is that corrosion engineering only gives you 3 parameters to tackle your corrosion problems. But corrosion management, if you use the right definition and concept, will provide you with more than 10 options to both identify and rectify your problems. And it makes sense to go ahead with the second option, which is corrosion management.
Yeah, thank you for your answer. But as our friends mentioned, it is hard to convince the manager, and they just need to see the statistical results. So, as you mentioned, it is helpful to have them as well. Thank you.
Oh, pleasure. As I mentioned to Mudassir, if you like, we can organize a short corrosion management presentation with your managers. And such financial figures for most companies, they are considered confidential. When you work for them as a consultant, they might share it with you, but you are not allowed to share it with the outside world for obvious reasons. So
Exactly, yeah. Sure. Thanks.
pleasure.
Thanks to Ali Morshed for the question. It's fascinating for me that I had just 2 questions, and 2 questions were asked and directly targeting my questions. There is a telepathy. So, yeah, if there is another question from the audience, I see like Thomas is here, president of EFC. Thank you for being here. Always the support from senior corrosionists, corrosion community is like good support for the young fellows. So I think there is no other questions. If there will be questions, you know Ali's contact information. Please email Ali, and Ali is always generous and kind to respond to the questions. And we are already reaching end of the session, and I will again thanks you, Ali, for the nice presentation, and thanks for the audience to be present in this session. We call it successful presentation already, lots of attendees, and thanks you again. Have a nice evening, nice day with whatever time zone you have, and happy again Corrosion Awareness Day.
Okay.